Okay, hello, Mr. Lee. So good evening. This is the second time for me to maybe to record this video to you. Yeah, this is very similar to a live show maybe, but it's just for our project. Okay, so right now this is the graph I've made randomly with curve, the tangent line, and the secant. I just set up 2 points randomly. So this is point A, which is regarding the coordinate with A plus H and FA plus H, and this is B, which is the coordinate with the coordinate A and FA, so that we can see that on the graph. The A point has a tangent line, and there's another secant line crossing through point A and point B, and so in the advanced function course, we've learned the method for us to calculate the secant line, which is like the FB minus FA divide B minus A. So over here, this is actually the point B, but for this time, I replace it with the A plus H, so that from this point, SH is an absolute value, so that if what if the the movement of edge, if the edge will be a positive number, so that the edge will maybe move to the right, and nonetheless if edge is a negative number, so the whole point will move to the left hand. So regarding the acknowledgement of the secant line, we can use a formula to get the actually secant from last semester. So for this topic, I just want to show that how the point A approaches point B. Point A is the coordinate of it is A plus H, and the edge A plus H, as is known to you all, right? So that we can see the slope of secant line is very not very close. It should be, yeah, it should be crossing the tangent line, so that we can probably say that if A plus H wanna this A point wanna approach B points, that the edge value should have to be very increasingly close to 0, but not equals to 0. Yeah, that's the point. So if I randomly choose a point, this is -3, so I use a proceeding to the left, so this is -5, I get another point. For instance, the point is A plus 2H, so if I wanna let it be close to A plus H, I should let one of the edge equals 0, so I can increasingly up and get this point from A plus H. The same as the following, so that if edge is 2, so that we can see the x values of A is -1, and the gap from A and A plus edge is 2. So if I use the following and put edge equals 2, then this point will move to the same spot of A. This is the point set about the limit I think about. So I will change another graph. Oh, sorry, that's not the graph, that's my calculation actually. So from the calculation, I just set up a new function in which f(x) equals x with the exponent of 3 by the time x will not equal 3, and moreover fx will equal 6 by the time x equals 3. So this is the preceding and following rules which we learned last semester to calculate the actual tangent. Once I just assume that the instant nearest rate of change at x equals -1. So these are the whole process for the calculation. I don't want to remain too much in this part. And over here, let's like make it bigger. Yeah, this is the new method which I just demonstrated by the graph. As edge approach 0, so by the time I only get 1 point is -1 and -1. This is coordinate. So I just put the same formula on it. I think I deem that this formula is the same as FB minus FA divide B minus A. Yeah, so I write down this formula, and by the time game h approach 0, and the following steps are all of my calculations, and as I seen to all, both of the answers are correct. They are identical for sure. The tangent is 3, and for this proceed and following method, tangent, when we get the average point, the tangent is also 3. So returning back to the graph before, we can see that no matter we use the proceeding or following, we will get the same answer if h is increasingly close to 0. Yeah, that's the main point for the limit, I think. That's about the rate of change, about instinct. Yes. So that's maybe pretty much it about my current presentation. So I hope I can have more suggestions and proposals from you, Mr. Lee. Thanks for watching.